Right. Okay. Good morning, students. So I told you that my class will be like an interactive session, as the previous classes will be discussing some new topics today. Yeah, and not only the new topics, right? We'll be solving some problems also, right? So today is class 2 of week 2. It is 12th of August 2020. Timing is 10:30 a.m. to 11:30 a.m. For the first 5 minutes, I gave you some what we say general instructions about assignment, how you have to submit the assignment. The Google form was posted to you, and I have told you how many students have submitted and how to submit the assignment, right? Okay. Now coming back to today's session, the main objective of today's session. See, after completion of this class, you should be able to identify the bars of varying section. What exactly is a bar and what are the bars of varying sections, cross section. Next, you should be able to evaluate the change in length of bar of varying cross section, and you have to interpret the relationship between stresses, strains, and elastic moduli. So these are the main topics which we are going to discuss in today's session, right? Okay. Now, before going to the actual things, right, bars of varying section. So in the last class, I have promised you that we are going to solve 2 more problems on the previous session. So if you are ready with a pen, paper and a pen or a pencil, then I'll explain this problem, then we'll go with the next one. You can solve this problem. I'll tell you how to solve the problem. This is for your assignment, okay? Today's assignment. You have to solve the problem, include this thing in your assignment and send it to me. Include this problem in the second assignment and you have to send it to me, right? Okay. See. So if you're comfortable, you can write down the question, or else I'll directly read out the problem and I'll explain you how to solve the problem. The question goes like this. Determine the change in length, width and thickness of a bar which is 4 meter long, 30 mm wide and 20 mm thick. So there are 3 dimensions which are given here. Which type of section is it? A 3-dimensional object which is having a length, width and thickness, right? It can be a prismoid or a cuboid, right? It's not a cuboid actually. It can be taken as some rectangular cross-sectional what we say area which is having some length of 4 meter. And this bar is subjected to an axial pull. Axial pull means what? You're pulling it in the outward direction along the axis. Along the direction of 4 meter length, you are applying the load. Now here in the question, they gave us modulus of elasticity capital E, which is equal to 2 into 10 to the power 5 megapascals, and Poisson's ratio is 0.3. Coming back to the solution, the first thing what you need to do is you have to identify and write down the given data. So what is the need of writing all this given data? So when you write the given data, it will be very easier for you to solve the problem without searching the question. So the data which is given to us is length of the bar, L, capital L. I'm just considering it as capital L, which is 4 meters. So 4 meter can be written as 400 centimeters, or you can write that one as 4000 millimeters. Now width of the bar, capital B, I'm taking width of the bar as capital B, which is taken as 30 millimeter. It is given to us. Next, thickness T is 20 millimeter. Axial pull capital P is equal to 30 kilonewton. That is 30 multiplied by 1000 Newton. That will be 30,000 Newton. Next, we have cross-sectional area. How to calculate the cross-sectional area? Can I multiply length with the width? No. Cross-sectional area is the width of the section multiplied by the thickness. That is 30 millimeter multiplied by 20 millimeter. That is 600 millimeter square. Now, Young's modulus is given to us 2 into 10 to the power 5 megapascals. 1 megapascal is equal to how much? Rule number 95, Raju.
Sir.
Rule number 95, Raju. Oh, Raju.
Sir.
Oka megapascal ante enta cheppu. How many newtons per mm square? 1 megapascal is how many newton per mm square?
Newton per millimeters.
1 newton per millimeters. Next, 65. Altaf Ahmad.
Sir, 1 Newton per millimeter square, sir.
1 newton per 1 millimeter square, right, is called as 1 megapascal. Next, 73. Bharat. Pascal, how much? How much is a pascal? Or what exactly is the value of pascal in newton per mm square or meter square? Unada? 73 Bharat, I am noting down your name. You are not responding. 74 Sushma. మీరు ఎవరైతే రెస్పాండ్ గారో ఫోన్ ఎవరైతే పక్కన పడేస్తారో వాళ్ళ నెంబర్స్ నేను నోట్ ఐఎమ్ జస్ట్ నోటింగ్ డౌన్ ద నెంబర్స్ హియర్ 24 Sushma. 1 pascal. How much is 1 pascal?
1 pascal is equal to 10 to the power of minus 3 MPa, sir.
Okay. Next, 96. Abdul Moin.
1 Newton per meter square. 1 pascal
1 Newton
equal.
per meter square. Right, very good. Okay. Moin. Abdul Moin. 96.
Sir.
Yes. Now tell me, give me some idea how to solve the problem. We have to determine the change in length, width, and thickness. Which
Yes,
formula
sir.
can be applied? Can you suggest me some formula? Which formula can be applied here?
Maybe stress.
What is stress? Can you give me a simple definition of stress?
Sir.
Cheppu, what is stress?
For sir, external force.
No. You're not reading. You're not studying at home. Next, 104. Arun,
Sir,
give me some idea how to solve the problem.
so we have to determine the change in length, width, and thickness. So we
Yes.
have to take the formula of strain.
Yes, very good.
Delta
Strain.
L by L.
See, change in length is available in which formula? It is available in strain formula. Right? Very good, Tarun. So, according to the definition which is given to us for strain can be written as a change in dimension to the original dimension, or change in length by original length, change in width by original width, change in thickness by original thickness. Right? Now, change in length is equal to strain multiplied by original length. Can I write it like that?
Yes,
Yes,
sir.
sir. We can.
Yes, you can write it like that, right? You can write it like that. And also, change in width, delta B can be written as strain multiplied by original width. Yes, okay. So here, this is the given data. Next, I'm revealing the formula which are available to us. Required formula. Longitudinal strain on lateral strain on any type of strain, whatever the strain you take, the formula will be same. Okay. Just look at the second formula, longitudinal strain. How can you write longitudinal strain as? Longitudinal strain means it is along the length. Lateral strain means it will be along the width and thickness. Babu, gurtupetukondi. Longitudinal strain will be along which direction? 100, Vishal. Mute, unmute.
Yes, sir.
Longitudinal
Yes, sir.
strain ఏ డైరెక్షన్ లో ఉంటది? లెంత్ డైరెక్షన్ లో ఉంటదా, విడ్త్ డైరెక్షన్ లో ఉంటదా, థిక్నెస్ డైరెక్షన్ లోనా?
Length direction ఉంటుంది, sir.
That's why it is called as longitudinal strain. Then lateral strain, 108, Ankita. Lateral strain, can you tell me, lateral strain will be along which direction? Will it be along the length or width
Along
or
width.
thickness? Along width. Can I take it along the thickness? Yes, you can also take it along the thickness. Right? Lateral means lateral dimension. Longitudinal dimension కాకుండా మిగతా డైరెక్షన్స్ లో ఉన్న డైమెన్షన్స్ ని lateral dimensions అని అంటారు ఇక్కడ. Right? Lateral dimensions can be taken as width, or you can also take that one as thickness. Right? Okay. See the first formula. Are the formula visible to you on the screen? Yes. Okay.
Yes, sir.
Longitude. Yes, very good. Longitudinal strain. Strain is represented as small e. Right? I can write that one as longitudinal stress divided by Young's modulus. Actually, I took the formula from Young's modulus. In the bracket, you can see since capital E, that is Young's modulus of the metal, which is equal to sigma divided by sigma ante stress. Which stress it is? Any type of stress. Tensile stress kaavachu, longitudinal stress kaavachu, compressive stress kaavachu, right? Except shear stress divided by E. E is corresponding strain. Suppose I am taking tensile stress, then E should be strain, tensile strain. Now from the same formula, small e can be written as sigma divided by. రాసుకోండమ్మా ఇవన్నీ మీకు ఇంపార్టెంట్ కదా. ఓ పేపర్ తీసుకోండి, పెన్ తీసుకోండి, వాటిపైన రాసేసుకోండి. ఇవన్నీ స్టెప్స్ 1 by 1 స్టెప్ నేను చూపెడుతున్నాను ఇక్కడ, చూపెట్టి మీకు సాల్వ్ చేస్తున్నాను ఎగ్జాంపుల్స్ లెక్క. So from next class onwards, I'll try to solve the problems on the board. I'll just put on a live session. I don't know whether my camera will support the long distance viewing or not, but I'll try. Okay, or else I will just try to record some video and I'll post it here. Okay, small e can be written as sigma divided by capital E. But longitudinal strain, we have the formula. See the second formula. What is the formula? Small e is equal to delta L by L. Delta L is change in length divided by capital L is original length. The third formula which is required here, increase or decrease in length of the bar or change in length. Delta L, from the second formula itself I took this one. Delta L is equal to strain multiplied by original length, E multiplied by L. And next we know the definition of Poisson's ratio. What is Poisson's ratio? It is generally represented as mu, which is the ratio of lateral strain to the longitudinal strain. A lateral strain, longitudinal strain. If you know both of these things, then we can calculate Poisson's ratio. Or if you want to calculate lateral strain or longitudinal strain, if Poisson's ratio is given to us, it is very simple to calculate. Now, lateral strain can be written as, fifth one, lateral strain can be written as E is equal to Poisson's ratio multiplied by longitudinal strain. Similarly, lateral strain can also be written as change in width by original width, or change in thickness, delta T divided by capital T. Lateral అన్నాను ఇక్కడ. Lateral అంటే lateral can be either it can be with respect to width or it can be with respect to thickness. See, seventh one. Now from the sixth formula, I have derived or I have obtained change in width delta B, which can be written as lateral strain multiplied by capital B, that is width. Similarly, change in thickness delta T can be written as lateral strain small e multiplied by thickness. So eighth one, seventh one, and third one, they appear to be same, isn't it? Yes. Now these are the required formulae which we need to solve the problem. Now I'm just going to substitute the values which are given in the problem, right, in these formulae. Just look at the screen now. Step number 2, application of formulae. So how did I apply the formula to get the answers? So first we need to determine the longitudinal strain. See, for obtaining the change in length, change in width, change in thickness, the only thing you require here is longitudinal strain. Okay, na? Yes. Change in length కావాలండి. Change in length అంటే delta L. Change in width కావాలి, delta B. Change in thickness కావాలి, delta T. So in order to get all these three things, right, the only thing which we require is lateral strain, right? Lateral strain ఉంటే మనకి or longitudinal strain ఉంటే ఈజీగా కనుక్కోవచ్చు, right? Now longitudinal strain, first formula, longitudinal strain is equal to longitudinal stress divided by Young's modulus. I have substituted the value. Small e is equal to sigma divided by E. Sigma can be written as load divided by area divided by capital. So that is 30,000 divided by 600, totally divided by 2 into 10 to the power 5. So I got the longitudinal strain as 0.00025. Longitudinal strain వచ్చేసింది ఇక్కడ. Now longitudinal strain, we have a formula delta L divided by L. So from this one, delta L, change in length, either it can be increase in length or decrease in length. Delta L is equal to small e multiplied by L. as the force is a pulling force, tensile force annani ikkada, it's not a compressive force. Will there be increase in length or decrease in length? 105 Santosh. Santosh 105. Is he
Yes,
present
sir.
here?
Yes, sir.
ఎలాంటి ఫోర్స్ అప్లై చేసాం ఇక్కడ? కంప్రెసివ్ ఫోర్సా టెన్సైల్ ఫోర్సా?
Sir, longitudinal tensile, sir.
ఎస్, టెన్సైల్. ఇంక్రీజ్ అవుతుందా లెంత్ డిక్రీజ్ అవుతుందా?
Increase, sir.
ఎస్, వెరీ గుడ్ సంతోష్, వెరీ గుడ్. Longitudinal strain, that is delta L divided by L. So delta L I have calculated, delta L is equal to E multiplied by L. Okay, same formula. So delta L, already E is known to us, 0.00025 multiplied by length of the bar is 4 meter, 4000 millimeter. So 0.00025 multiplied by 4, right? So I can take that one as 1 millimeter. I got the answer as 1 millimeter. Okay, right. Now Poisson's ratio, mu, already we know that one. It is the ratio of lateral strain by longitudinal strain. Lateral strain by longitudinal strain. So that can be written as, lateral strain can be written as Poisson's ratio multiplied by longitudinal strain. ఈ రెండు వాల్యూస్ తెలుసండి మనకి. Poisson's ratio 0.3 ఇచ్చాడు, longitudinal strain మనం కనుక్కున్నాం 0.00025, and 0.3 multiplied by 0.00025, we got small e is equal to 0.00075. Okay, 97 Rajesh, lateral strain ki units ఏంటివి చెప్పు. ఉన్నాడా రాజేష్? 97 Rajesh not responding. I'm noting down the roll number. Next 98 Venkana, ఇతను కూడా లేడు. 102 Himachandar.
Yes, sir. No units, sir.
వెంకన్న చెప్పు. 98 వెంకన్న చెప్పు. దీనికి యూనిట్స్ ఏంటివి చెప్పు, లాటరల్ స్ట్రెయిన్ కి?
లాటరల్ స్ట్రెయిన్ సార్
చదువుతలేవు ఇంటి దగ్గర. స్ట్రెయిన్ అంటే డెల్టా ఎల్ బై ఎల్, అంటే ఎల్ డివైడెడ్ బై ఎల్ అన్నట్టే కదా. దాని యూనిట్స్ మిల్లీమీటర్, దీని యూనిట్స్ మిల్లీమీటర్, రెండు స్ట్రైక్ ఆఫ్ అయిపోతాయి. విల్ దేర్ బి ఎనీ యూనిట్స్ ఫర్ స్ట్రెయిన్? 113 లాసియా, శ్రీ లాసియా 113. What are the units of strain? What are the units of strain?
No units, sir.
No units. No units. Okay, very good. Very good. Very good. Very good. You can mute now. Right. So lateral strain, we obtained that one as 0.00075. Now lateral strain can also be written as change in width to the original width, change in thickness to the original thickness, change in length to the original length, right? So my intention is to calculate the change in width. Change in width allows the lateral strain multiplied by capital B. Seventh formula, seventh equation. Lateral strain E multiplied by capital B. So delta B is change in width. Already lateral strain we have calculated 0.00075 multiplied by 30. So I got the value as 0.00225 millimeters. There is a mistake here. Can you identify the mistake? Anyone? Be attentive in the class.
Sir, no units.
Inka.
సార్ ఆన్సర్
ఇంకా చెప్పండి. ఏం లేదండి, మిస్టేక్ ఏం లేదు. జస్ట్ యూ షుడ్ బి అటెంటివ్ ఇన్ ద క్లాస్ టు మేక్ యూ యాక్టివ్ ఇన్ ద క్లాస్. ఐ టోల్డ్ యూ దట్ దేర్ ఈస్ సమ్ మిస్టేక్, యూ హావ్ టు ఐడెంటిఫై. ఓకే, డెల్టా బి ఈస్ నథింగ్ బట్ చేంజ్ ఇన్ విడ్త్, రైట్? విడ్త్ అన్నాను అక్కడ. విడ్త్ మీన్స్ వాట్? ఇట్ విల్ బి హ్యావింగ్ సమ్ యూనిట్స్, రైట్? Is that okay for you? Okay, the units of width delta B, change in width is 0.00225 millimeters. So there may be some slight change in the values, don't worry. You will be using some modern calculator, I am using some very old calculator, so there may be some difference in the numerics. Change in thickness, similarly change in thickness, eighth one, delta T, which is equal to lateral strain multiplied by capital T, thickness. Same thing again. Delta T is equal to 0.0075 multiplied by 20. We got the value as 0.0015 millimeters. Now these three things are the answer. Lateral strain, change in length, change in width, change in thickness. Now a question to you. Which one is increasing and which one is decreasing? Among these three things, delta L, delta B and delta T. Delta L ఉన్నది ఇక్కడ, delta B ఉంది, delta T ఉంది. Open question. First ఒకరు చెప్పండి.
Only delta L is increased.
Only delta L is increasing. Who is that? What's your name?
64, sir.
Right. Very good. Very good. Chakradhar. Only delta L is increasing.
Remaining
When delta L is increasing, what happened to the other one? Delta B and delta T. Will they increase or decrease?
they will decrease.
Okay. Right. Very good. 112. Unnada? 112?
Present, sir.
Tell me why delta B and delta T are decreasing.
సార్ మనం
Delta-
టెన్సైల్ ఫోర్స్
చెప్పు.
టెన్సైల్ ఫోర్స్ అప్లై చేసినప్పుడు లెంత్ ఇంక్రీజ్ అవుతుంది కదా సార్.
Hmm.
లెంత్ ఇంక్రీజ్ అయినప్పుడు థిక్నెస్ విడ్త్ డిక్రీజ్ అవుతుంది అనుకుంటున్నా సార్.
Obviously it will decrease. Obviously it will decrease. You can just check this thing with a simple experiment, right? Students,
Yes, sir.
your friends, they are explaining, they are telling that when a tensile force is applied on any material, right? That means you are pulling it apart, right? Length of the material will be increasing and lateral dimensions, lateral and thickness as well as width of that section will be decreasing. To check whether it is same or not, right? I'll tell you simple example. Suppose many of you people are using a rubber band, right, for many things, right? To bind the cash or books or something else. Rubber band ఉంటుంది. Just hold the rubber band and see the thickness of the rubber band will be around 1 millimeter to 3 millimeter. It will be having some length, right? Now when you stretch the rubber band, what is happening over the length will be increasing. But when you see the thickness of that one, what is happening there? Thickness of that band, rubber band, which is elastic material here, will be decreasing. It will be obviously decreasing, right? It is similar to your elastics, right? Masks use చేస్తున్నారు చాలా మంది. మాస్క్ కి ఎలాస్టిక్ ఉంటుంది. ఎలాస్టిక్ ని కూడా పట్టుకొని లాగి చూడండి. The thickness of that one will increasing or decreasing. It will be decreasing. Length will be increasing, whereas thickness will be decreasing. So lateral dimensions will be decreasing. So this is a problem, right? So this type of questions will be asked in the examination. It is a lengthy problem actually. It will carry around 6 marks in the external examination. This type of questions will be asked. Okay. So is it okay for you? Do you have any doubts in this problem? If you don't have any doubt, then I'll go with the next question.
No, sir.
Right.
No,
Very
sir.
good. Very good. Okay. I hope everyone is
Yes.
comfortable with
Sir.
this problem. Yes. Ask.
సార్ ఇప్పుడు టెన్సైల్ ఫోర్స్ అప్లై చేసిన కాబట్టి లెంత్ ఇంక్రీజ్ అవుతుంది సార్.
అవును.
కంప్రెసిబుల్ స్ట్రెస్ అప్లై చేస్తే లెంత్ డిక్రీజ్ అవుతుంది సార్.
Compressible?
ఇప్పుడు కంప్రెసిబుల్ స్ట్రెస్ అప్లై చేసినాం అనుకో అది
Ah.
థిక్నెస్ అవి ఇంక్రీజ్ అవుతాయి సార్.
అవును, ఇంక్రీజ్ అవుతుంది. టెన్సైల్ ఫోర్స్ అప్లై చేసినప్పుడు లెంత్ ఇంక్రీజ్ అవుతుంది. అదే ఉల్టా వైస్ వర్సా కదా. సపోజ్ ఇఫ్ యూ ఆర్ అప్లైయింగ్ కంప్రెసివ్ ఫోర్స్. మనోజా మాట్లాడేది?
112 సార్ చారి.
చారి, ఇప్పుడు కంప్రెసివ్, సపోజ్ ఐఎమ్ కంప్రెసివ్ ఫోర్స్. ఓకే, వెరీ గుడ్ చారి, యూ హ్యావ్ ఆస్క్డ్ ఎ వెరీ గుడ్ క్వశ్చన్. If tensile force is applied, length is increasing and lateral dimensions are decreasing. If compressive force is applied, then what will happen? Length will decrease. When length is decreasing, what will happen to the lateral dimensions? It will increase. Okay, lateral dimensions will increase. ఇక్కడ గుర్తుపెట్టుకోవాల్సింది ఒకటేనండి, either tensile force or compressive force, whether change in dimensions, lateral dimensions or original dimension, volume of the material should not change. Okay, here volume of the material will not change unless and until you are applying all the three forces in three directions. Okay, same ఉంటుంది వాల్యూమ్, ఇక్కడ సేమ్ వస్తుంది. Okay, is it clear to you?
Yes sir.
When tensile force is applied, length will be increasing and width and thickness will be decreasing. When compressive force is applied, length will be decreasing, whereas thickness and width will be increasing. Just remember that. Okay, very good question. Okay, be attentive and ask this type of questions. All the students should ask me a question. Right. Okay, I'm going with the next question now. Problem number 4. ఇక్కడ చూడండి అమ్మా, ద క్వశ్చన్ గోస్ లైక్ దిస్: ద అల్టిమేట్ స్ట్రెస్ ఫర్ ఏ హాలో స్టీల్ కాలమ్. హాలో స్టీల్ కాలమ్ అంటే సింపుల్ ఎగ్జాంపుల్ పైప్ అనుకోవచ్చు అండి. పైప్ కాలమ్ అంటే వర్టికల్ మెంబర్ విచ్ ఇస్ సపోర్టింగ్ ఎ స్లాబ్ ఆర్ ఎ రూఫ్ ఆర్ ఎనీ హారిజాంటల్ మెంబర్. Ultimate stress for a hollow steel column which carries an axial load of 3 meganewton అన్నాడు ఇక్కడ. మెగాన్యూటన్, ఇట్ ఇస్ నాట్ కిలో న్యూటన్. కిలో మీన్స్ 10⁻3, mega means 10⁻6. The ultimate stress for a hollow steel column which carries an axial load of 3 meganewton is 520 megapascals. అల్టిమేట్ స్ట్రెస్ ఇచ్చాడు ఇక్కడ. అల్టిమేట్ స్ట్రెస్ అంటే మాక్సిమం ఇక టోటల్ స్ట్రెస్, దానిలో కూడా ఎంతైతే రెసిస్టెన్స్ ఆఫర్ చేయగలదో అంత స్ట్రెస్ అన్నట్టు అల్టిమేట్ స్ట్రెస్. Then what is permissible stress? Suppose if you're taking a material, you are applying 100 Newton force, right? 100 Newton force. Up to 100 Newton force, what will happen? It will resist some, what we say, the load. So after 100 Newton, there will be some permanent deformation. Okay? Permissible stress antaru ikkada vachedi. Ultimate stress for a hollow steel column which carries an axial load of 3 meganewton is 520 megapascal. If the external diameter of the column is 300 mm, pipe annani ikkada 300 mm diameter, external diameter, then it will be having some internal diameter also. Determine the internal diameter. Take factor of safety as 4. Factor of safety ఇచ్చాడు క్వశ్చన్ లోనే. అంటే డైరెక్ట్ గా మీరు అర్థం చేసుకోవచ్చు ఇక్కడ ఏంటిది. We have to use the formula for factor of safety. Factor of safety is ultimate stress by permissible stress.
Ultimate stress by permissible stress.
Yes, very good, very good. So factor of safety is given as 4. Okay, right. Now, given data, I'm just reading out the data. Axial load is given to us on the column. I'm taking that one as capital P, which is equal to 3 meganewton. That is 3 into 10⁻6 newtons. Next, ultimate stress is given to us. Either it may be ultimate stress or some other type of stress. It is always represented as sigma only. Sigma, which is equal to 520 megapascals. Next, factor of safety is given as 4. External diameter is given as 300 millimeter. I'm assuming that internal diameter of the column as small d. Let small d be the internal diameter of the section or column. Now tell me how to solve this problem. Anybody? Varun Reddy, 107. Which type of formula can be used in here? How many formula can be used? Okay, Varun Reddy is not responding. Next, 68, Arun Sai. 68 is also not responding. Right. Next, 69, Fayaz. I'm noting down all the roll numbers, those who are not responding here. 69, Fayaz. Sheikh Fayaz.
Yes, sir. Yes, sir.
Cheppandi. Tell me,
Sir.
which formula can be applied here? Just look at the screen, read the problem, and tell me how many formula can be used here, or which type of formula can be used. Just guess and tell me. There is no mistake in giving some correct or wrong answer.
Stress. Factor of safety. Maximum stress.
Factor of safety, right? You can use factor of safety, right? Very good. 78, Vishnu Rathod.
Yes, sir.
Yes, tell me what is factor of safety now.
Factor of safety.
78.
Safety. What will say?
Okay, 81, Vivek.
Can I answer it? Sir.
Ultimate stress by
permissible stress.
Okay, right. Very good. Very good. Okay, that's okay. Very good. Okay, no problem. Those who are not giving the answer, that's not what we say a mistake. కొద్దిగా ప్రాక్టీస్ చేయండి. ప్రాక్టీస్ చేస్తే నెక్స్ట్ క్లాస్ నుంచి మీకు అర్థమైపోతుంది. ఆర్ మీరు రాసుకున్న నోట్స్ ఏది ఉంటుందో ముందర పెట్టుకోండి అమ్మా, అడగగానే క్వశ్చన్ చెప్పడానికి. Okay, that's okay, no problem.
Okay.
So answer చెప్పకుండా పర్లేదండి, no problem. If you are responding, that's well and good, because these are the just initial classes, and you are not practicing at this time, I can understand. So whenever I'm asking you some question, suppose you are writing in your notebook, right, that will be helpful for you. That's why I told you to write down the important points and all these things in your notebook, right? సార్ క్వశ్చన్ అడగంగానే ఏం చేయాలి? క్వశ్చన్ ఆల్రెడీ మీ దగ్గర నోట్బుక్ ఉంటుంది కాబట్టి జస్ట్ యూ కెన్ టర్న్ ద పేజెస్ అండ్ యూ కెన్ ఎక్స్ప్లెయిన్, యూ కెన్ టెల్. Okay, like that you can just interact with your faculty. That's well and good. Okay, step 1, formula required. How many formula we need here? Cross sectional area, factor of safety, and permissible stress. Cross sectional area ikkada ostadi nenu cheptanu. Permissible stress is, or simply I can call that one as stress, right? Load divided by area. Ultimate stress divided by permissible stress is factor of safety. So we need cross sectional area also. Why cross sectional area is required? So in the question they asked us to determine the internal diameter. The only formula where internal diameter can be calculated or applied is cross sectional area. Cross sectional area. 111 Dheeraj, can you tell me what is the cross sectional area formula for a circle? Roll number 111 Dheeraj. Circle area enti cheppu? Cross sectional area.
Pi by 4 into d square minus d square minus
circle చెప్పవన్నా.
pi r
Circle
square, sir.
డయామీటర్ ఇచ్చినప్పుడు ఏమవుతుంది మరి? 5/4 d square అయితే. నెక్స్ట్ 119 Ritika. 119 Ritika.
Yes, sir. Yes, sir.
Hollow circular section. Hollow circular section which is having a diameter of capital D and internal diameter small d. External diameter is capital D, internal diameter is small d. What will be the cross sectional area?
5/2, sir.
5/2
d square minus
5/4. Hollow section. Hollow ante it's like a pipe, right? There will be not semicircle, circular.
Circular 5/4, sir.
చెప్పండి ఫార్ములా చెప్పండి.
5/4 capital D square minus small d square.
Okay, right, very good. So these are the formula which are required to us, right? So మనకి ఏం అడిగాడు ఇక్కడ? Small d, right? Small d need to be calculated. So applying factor of safety is given to us. How much is factor of safety? It is 4. Ultimate stress is also given to us, 520. Permissible stress is unknown to us. Can we determine permissible stress formula for factor of safety formula? Yes, we can. So I'm applying the values. Factor of safety is 4. 520 is the ultimate stress and permissible stress is unknown to us. From that we have calculated permissible stress, which is 520 divided by 4. That is 130 megapascal. MPa, it is wrong here written. It should be capital P. Megapascal. Okay. Now permissible stress is known to us. What is permissible stress? Simply it is load divided by area. Allowable stress, you can also call that one as allowable stress. అంటే ఎంతవరకు అలో చేస్తుంది, లోడ్ ఎంతవరకు అలో చేస్తుంది, ఎంత అలో చేసిన లోడ్కి ఎంత స్ట్రెస్ డెవలప్ అవుతుంది. లోడ్ డివైడెడ్ బై ఏరియా, రైట్? పర్మిసిబుల్ స్ట్రెస్ ఇస్ 130. ఐఎమ్ జస్ట్ ఈక్వేటింగ్ దీస్ టు. 130 ఈజ్ ఈక్వల్ టు లోడ్ ఇస్ 3 × 10⁶, 3 mega Newton divided by area, 5/4 multiplied by 300 square minus d square. 300 square minus small d square. Now when you solve this thing, simplify this thing, you will get small d which is equal to under root of something, right? So I have obtained small d which is equal to 246.20 millimeter. External diameter is 300 millimeter. Internal diameter is 246 millimeter. మరి ఇప్పుడు పైప్ థిక్నెస్ ఏంటో చెప్పండి. Can anyone tell me what is the thickness of that section? Pipe thickness. External diameter is 300. Internal diameter is 246. What is thickness of the
54.
53.80 millimeter. 53.80 millimeter. Antena? Capital D minus small d will give us the thickness of the section. Pipe thickness on it, metal thickness. Okay, that's well and good. Okay, right. So now from now onwards, be attentive, okay? And try to open a fresh page and write down a new topic, that is bars of varying section. Bars of varying section. What do you understand by the term bars of varying section? there is a picture which is shown on the screen, right? So 3 or 4 different sections or different bars, either they are rectangular or circular or combination of both, which are connected together, which is applied with some load, right? So it can be called as a bar of varying section, a composite section. So bars of varying section, we can calculate the length, we can calculate the stresses which are developed in this particular. Okay. Now here on the screen, you can see, I'm just considering a bar and a rod, which is having 3 different cross sections. Section 1, section 2, and section 3. Let A1, L1, L2, A2, and L3, A3 be the length and area of the first section, second, and third sections respectively. So first section తీసుకున్నాను, section number 1 అని ఉంది అక్కడ, dark yellow color లో. Section number 2 light green color. Section number 3 is dark green color. Section number 1, what is the length of section number 1? It is given as L1. Cross sectional area is A1. Section number 2, its length is L2. Cross sectional area is A2. Section number 3, its length is L3. Cross sectional area is A3. Now, capital P, let us assume that capital P is the area, not area, sorry, axial load which is acting on the bar. Now, which type of loading I am considering here? As you can see, it is a tensile load. You can also go with a compressive load. Nothing will happen. Axial load which is acting on the bar. Capital P is the axial load which is acting on the bar. Okay. Now, first section తీసుకుంటున్నాను ఇక్కడ. Just if you have some time, you can draw the section 1. Section 1 rectangle draw చేసుకోండి, L1, A1 అని indicate చేసుకోండి సరిపోతుంది. See, I'm assuming that Young's modulus of this entire cross section is same. Let capital E be the Young's modulus of the entire cross section. Now, when I take section 1, the formula to calculate Young's modulus capital E will be stress divided by strain. Stress in the first cross section and strain in the cross section will be different from section 2 and section 3. Can you tell me why? Anyone? ఇక్కడ 3 different cross sections ఉన్నాయి కదా, చూడండి అమ్మా, ఇక్కడ సెక్షన్ నెంబర్ 1, సెక్షన్ నెంబర్ 2, సెక్షన్ నెంబర్ 3. ఈ 3 different క్రాస్ సెక్షన్స్ కి 3 different లెంత్స్ ఉన్నాయి, 3 different ఏరియాస్ ఉన్నాయి. కానీ లోడ్ మాత్రం ఒకటే అప్లై చేశాను ఇక్కడ. ఐఎమ్ అప్లైయింగ్ ఓన్లీ వన్ లోడ్, వన్ టైప్ ఆఫ్ లోడ్ ఆన్ ద సెక్షన్. Now, can you tell me stress in section 1, stress in section 2, and stress in section 3, as well as strain in section 1, strain in section 2, strain in section 3. ఈ 3 సెక్షన్స్ లో స్ట్రెస్ స్ట్రెయిన్ సేమ్ ఉంటాయా, డిఫరెంట్ ఉంటాయా? డిఫరెంట్ ఉంటాయి. ఎందుకు డిఫరెంట్ గా ఉంటాయి చెప్పండి?
క్రాస్ సెక్షన్
Very good, my dear students. You are absolutely right. Now, I want this type of spirit from you people. Interaction. Cross sectional area different ఉంది కాబట్టి స్ట్రెస్ డిఫరెంట్ వస్తుంది. స్ట్రెస్ కి ఫార్ములా ఏంటిదంటే సిగ్మా డివైడెడ్ బై క్యాపిటల్ ఏ. ఓకే, సిగ్మా డివైడెడ్ బై క్యాపిటల్ ఏ. సిగ్మా అంటే సిగ్మా కాదండి, క్యాపిటల్ పి డివైడెడ్ బై క్యాపిటల్ ఏ, రైట్? Stress sigma is equal to capital P divided by capital A. Now, when A is decreasing, obviously stress will be decreasing. Now, A1, A2, and A3 are 3 different stresses areas here. Now, what will happen to sigma 1, sigma 2, and sigma 3? They will be varying again, right? And stress is inversely proportional to area. Stress is directly proportional to the load, right? Sigma is equal to P divided by capital A. And when load is increasing, stress will be increasing. When area is increasing, what will happen? Stress will be decreasing. Inversely proportional. Okay, right. Now, just look at the first section 1. I get a first section. We know the formula of Young's modulus. E1 is equal to sigma 1 divided by E1. Capital E is equal to sigma 1 divided by small e1. But stress sigma 1 can be written as capital P divided by A1. రాసుకోండి అమ్మా ఇవన్నీ. స్ట్రెయిన్ ఎలా రాయొచ్చు మరి? చేంజ్ ఇన్ లెంత్ బై ఒరిజినల్ లెంత్, డెల్టా L1 డివైడెడ్ బై L1. సో దాన్నే నేను ఎలా రాశానంటే PL1 డివైడెడ్ బై డెల్టా L1 ఇంటూ A1 కిందికి వచ్చేస్తుంది, L1 పైకి వెళ్ళిపోతుంది. క్యాపిటల్ E కెన్ బి రిటర్న్ యాజ్ PL1 డివైడెడ్ బై డెల్టా L1 ఇంటూ A. Now దీంట్లో డెల్టా L1 is shifted to E is shifted to the denominator. Now what will be delta L1 from the same formula? Delta L1 can be written as P into L1 divided by A1 into E. P1 E1 తీసుకోవట్లేదు, ఎందుకు అని అంటే యంగ్స్ మాడ్యులస్ ఆఫ్ ద ఎంటైర్ బార్ ఇస్ కాన్స్టెంట్ అని చెప్పాను ఆల్రెడీ. అండ్ P is the load, a single load, a constant load, a tensile load which is applied over the entire cross section. I'm not taking P1, P2 and P3, three different loads which are applied, right? Only one capital P which is applied over the entire section. Okay, now we got delta L1. What is delta L1? Delta L1 is nothing but elongation of section 1. Elongation in section number 1. Now similarly, can I write down the formula for section number 2, delta L2? Now delta L2 can be written as PL2 divided by A2 into E. Now similarly, can I write down the formula for delta L3? Delta L3 can be written as PL3 divided by A3 multiplied by E. Right. Now, if I take total change in length as delta L, total change in length of the bar, combining delta L1, delta L2 and delta L3, you will get total change in the length. Delta L can be written as delta L1 plus delta L2 plus delta L3. Already we know delta L1 is PL1 divided by A1E. Delta L2 is PL2 divided by A2E. And delta L3 is PL3 divided by A3 multiplied by E. Very simple formula, PL by AE. Now simplifying or generalizing the formula, right? I can write down this one as delta L can be written as sigma PL by A. Sigma PL by A. Suppose there are three sections. It can be written as PL1 divided by A1E, PL2 divided by A2E, PL3 divided by A3. For generalizing the formula, you can write that one as sigma PL by AE. Now this is the main formula. ఈ ఫార్ములా గేట్ ఎగ్జామ్ లో ఖచ్చితంగా వస్తుందండి. కీప్ ఎ స్టార్ మార్క్ టు దిస్ ఫార్ములా అండ్ రైట్ డౌన్ అట్లీస్ట్ 3 questions will appear in the gate examination based on this formula. And in public service examination, nearly 4 to 5 questions will appear. Okay, principle of superposition will be explained tomorrow. Don't worry about principle of superposition. Now a question to you all. If Young's modulus of the first section, Young's modulus of second section and Young's modulus of third section are totally different, then what will happen? The formula will be same, but PL by A will be a constant. P into L divided by A will be a constant. And you have to take E separately. 1 by E1 plus 1 by E2 plus 1 by E3. Or P divided by cross-sectional areas, right? Or P will be constant. L1 by A1 E1, L2 by A2 E2, and L3 by A3 E3 will be taken out separately. Okay. So this formula is very important. You have to please make a note of this formula. Any doubts up to here?
No, sir.
No, sir.
Right. Okay. Shall I go with the problem based on this one?
Yes, sir.
Right. Okay. Very good. Right. Right on. Problem number 5. Very important question. Very important question and very simple question. A steel rod 1 meter long and 20 mm by 20 mm in cross-section area. That means it is a square rod. A steel rod, the length of the rod is 1 meter. A steel rod 1 meter long and 20 mm by 20 mm cross-sectional area is subjected to a tensile force of 40 kilonewton. Is subjected to a tensile force of 40 kilonewton. That means 40 into 1000, 1000 Newton. 40,000 Newton. Determine the elongation of the rod if the modulus of elasticity of the rod material is 200 GPa and 200 GPa, 200 gigapascals. Can you tell me how much is 1 gigapascal?
10 power 12, sir, I
10 to power
think.
of 10 to power of
10
9.
power?
10 power 9, sir.
10 power 9.
Yes,
Nine,
yes.
nine.
Okay,
9.
right. Very good, very good. Very good, very good. 10 power 9 gigapascal. Okay, 10 power 9 pascals. Okay, that's well done. Now, I'm just writing down the given data here. The length of the section is given as 1 meter. 1 meter means 1 into 10 to the power 3 millimeters. Now, cross-sectional area is given as 20 by 20 millimeter. 20 into 20 is 400 millimeter square. So tensile force is given to us. Tensile force is 40 kilonewton. That is 40 into 10 to the power 3 newtons. Okay, 40,000 newton. And modulus of elasticity is given to us 200 gigapascal. That means 200 into 10 to the power 9 Newton per mm square. So it is printed as 10 to the power 3. Okay, just change it to 10 to the power 9. Correction cheskoru. Chinna mistake padindandi. This one, right? So it has to be some other thing. Here also I have made some mistake, right? Calculation part. Okay. Now the formula required. There is only one simple formula which is required. Or you change this one to 200 megapascal. In the question, you change that one to 200 megapascal. I'll change it now itself. 200 MPa, 200 into 10 to the power 3. Okay, so, let it be. It is correct only. Okay, is it visible to you? Students?
Yes, sir. Yes, sir.
Yes, we'll modify that one later. So I'm directly substituting the values here. 40 into 10 to the power 3 multiplied by the length is given as 1 into 10 to the power 3. I mean to say that is 1000, 1 meter, that 1000 millimeter divided by area. Cross-sectional area is given as 400 multiplied by 200 into 10 to the power 3. I'm just making it like that only. Okay. So I got delta L. Delta L means change in length, which is equal to 0.5 millimeter. 0.5 millimeter. Right. Okay, I think you have written down that question. Right. Next, let us go with the next one. Problem number 6. Write down the question. A hollow cylinder, 2 meter long, has an outside diameter of 50 millimeter and inside diameter of 30 millimeter. The cylinder is carrying a load of 25 kilonewton. If the cylinder is carrying a load of 25 kilonewton, find the stress in the cylinder. Also find the deformation of the cylinder. If the value of modulus of elasticity of cylinder is 100 GPa. 100 GPa. Make a note of that question. Make a note of that question. Okay. Finished? Right. Now,
No.
not yet finished. Okay, make it first. Gigapascal and ikkada intamundu antlo kuda correct unnadi actually. That is correct only. 1 gigapascal which is converted into 1 Newton per millimeter square. It is 1 gigapascal equal to 1000 MPa. 1 gigapascal it is equal to 1000 MPa. So here, modulus of elasticity is given 100 gigapascal. That means how much will it be? 100 into 10 to the power 3 Newton per mm square. In the previous problem also it is correct only, 10 to the power 3 only. Don't change it. Right. So, finish writing? Yes.
Yes, sir.
Right, very good. Okay, very good. See, I took the question from one of the GATE textbooks, GATE solutions textbook, right? I found this one as interesting. That's why I took it. So, given data, length is given to us, that is 2 meter, that is 2 into 10 to the power 3 millimeter. Outside diameter, let us take that one as capital D, which is equal to 50 millimeter. Capital D. Inside diameter, let inside diameter be small d, that is equal to 30 millimeter. And load, capital P is given to us, that is 25 kilonewton. So how much is 25 kilonewton? 25 multiplied by 10 to the power 3. (25 into 10 to the power 3). Next one, modulus of elasticity. Modulus of elasticity, capital E is given as 100 GPa. 100 GPa. That is 100 multiplied by 10 to the power 3 Newton per millimeter square. Do remember this one. 100 into 10 to the power 3 Newton per millimeter square. Now, the first thing which we need to do here is we have to calculate the stress in the cylinder. Right? What is the formula to calculate stress? It is P divided by capital A. P is load divided by capital A is the diameter. Capital A is the cross-sectional area with the diameters capital D and small d. Now load is given to us, that is 25,000 newtons. The cross-sectional area can be easily calculated. How can you calculate cross-sectional area? Capital A is equal to pi by 4 into capital D square minus small d square. That is pi by 4 multiplied by 50 square minus 30 square, which is equal to 1257 millimeters. Now we got the load and we got the cross-sectional area. We can calculate the stress. Stress is equal to P by A. That is 25 into 10 to the power 3 divided by 1257. Obviously, you'll get around 20 megapascal. That is 19.9 megapascal. Load is in Newton. Cross-sectional area is in millimeter. Newton per millimeter square is megapascal. Okay, next, the question, in the question, they have asked us to determine the deformation of the cylinder. Deformation means change in length. So, we already have a formula to calculate the change in length, right? What is that formula? PL divided by A into E. Delta L is equal to PL by AE. So P is known to us, load which is 25 into 10 to the power 3. Length is known to us 2 into 10 to the power 3 millimeter. Cross-sectional area is calculated, that is 1257 millimeter square. And Young's modulus of the metal is also known to us 100 GP, 100 into 10 to the power 3 Newton per mm square. Now substituting all the values and calculating, we get delta L, change in length, which is equal to 0.4 millimeter. We'll get delta L, which is equal to 0.4 millimeter. That means there will be an increase in length, which is equal to 0.4 millimeter. Now this is a question to you. Okay, you write down this question and try to solve this question. Problem number 7.
Sir,
Yes.
once show the previous slides.
Yeah, I'm showing it. Make a note of it. Right. So shall I go with the next one? If you have completed.
Yes, sir.
Right. So this is homework for you. Try to solve this problem. So if you are unable to solve it, then we'll do it in the next class. In an experiment, a steel specimen of 13 mm diameter was found to elongate 0.2 mm in a 200 mm gauge length. When it is subjected to a tensile force of 26.8 kilonewton. If the specimen was tested within the elastic range, what is the value of Young's modulus of steel specimen? What is the value of Young's modulus of the steel specimen? Okay, don't worry. I'll share the slides. Okay. And I'll also post the same question. Try to solve the question. So if you're comfortable with this thing, you can solve it, or else we'll solve it in the next class. Now, just I'm ending the PPT here. So I have got the solution with me. Now let me take the attendance. Right, dear students, do you have any doubts regarding today's class? Now it is an open session to you all. Do you have any doubts regarding today's class? Any doubts? Okay, thank you very much. I don't have any doubt.